Next, we have a review of circles. You should have talked about circles a little bit in at least Algebra 2. And so if we walk through here on how the book approaches our circles here, they're looking at figure 1.7. So we're looking at the picture here. And it says a point xy is on the circle if and only if its distance from the center, and our center is always called, or always use the variables h and k for the center, is the radius. So what that means is if you have a point on the circle, any point here, if I use the distance formula, so this distance equals the radius of the circle. So if I don't know the radius, but I know the center point, and I know an xy point on the circle, I can always find the radius by using the distance formula. So the distance formula is actually how we arrive at getting the standard form of our equation. Our standard form of our equation, a good thing to highlight, put a circle around, whatever it might be, is x minus h squared plus y minus k squared equals radius squared. And this is your standard form. So remember the h and the k are the center. And then your radius, your r is the radius. And notice how all of them in this standard form are squared. So just something to keep in mind there. Let's fix my grammar here a little bit. I think this should say h and k is the center. There we go, that's better. Okay. All right, so if you have a standard form of the equation with the center at the origin, so what that means then is that the center is 0, 0, then we have this nice and simple equation, x squared plus y squared equals r squared. So if the center is at 0, we don't have any additional numbers with our x and our y, because zeros, we don't put those in. Here is an image of a circle with a center at the origin. So we got our center at 0, 0, and then it goes in all directions, whatever the radius is, it goes in all directions, and then is connected with that nice smooth circle. Now you'll notice on the answer key, my sketches are not on Notability, so I don't have a perfect circle to use, but if you use Notability, you have the access to those nice shapes where you can draw pretty precisely with your graphs. So here's an example of writing an equation of a circle. We're given the point 3, 4 is a solution point of the circle, which means it's on the circle, and its center is negative 1, 2. And then here's a picture of it. Write the standard form of the equation of the circle. So we have some points. We have the center, negative 1, 2. We have the point 3, 4 on the circle. We have the picture of the circle. We need to write the equation. So here's our standard form. We need h and k, and we have that. We have negative 1 and 2, but we don't know the radius. That's what we need to figure out. Well, on the previous slide, it gave the definition as the distance between the center and the point on the circle equals the radius. So if I can use the distance formula and find that specific distance, that is my radius. So we're going to use then our distance formula, and we're going to find the distance between negative 1, 2, which is the center, and then the 3, 4, which is the point on the circle. So if we substitute in, we'd get that r equals the square root, because this is our distance formula here. So then we'd have x minus h, so h is negative 1, k is 2. So x minus a negative 1, which we know is going to be positive, and we're going to square that, plus y minus k, which is 2 squared. Now you might be thinking, well, there's still an x and there's still a y, so how is this helpful? Well, you have the point 3, 4, and that point is x and y. So we have values actually to substitute in for x, y, h, and k. So I can go ahead and I know that x is 3, so I can substitute 3 in here. So I'd have 3 plus 1 squared plus, and then our y value over there is 4. So this would be 4 minus 2. Now I can get an actual number value instead of having variables in there. So we are given enough information because we have the center and a point. So this gives us a square root. 3 plus 1 is 4, squared is 16, plus 4 minus 2 is 2, squared is 4. So our radius is the square root of 20. Now we don't have to simplify the square root because in the formula, in our generic equation of a circle, and I'm going to rewrite that here. So our equation, x minus h squared plus y minus k squared equals r squared. We're going to square this anyway, so we actually won't have a square root left in our answer. So our final answer then for standard form, x minus, remember our h and k value was negative 1, 2 for the center. So h would be a negative 1, so it'll be a plus 1 there, squared, plus y minus k, which was 2, squared, equals. Now if we do the square root of 20 squared, remember the square root and squaring are inverse operations, so they undo each other. It's like we have root 20 times root 20, which if you multiply it out is root 400, which is just 20. So our final answer, x plus 1 squared plus y minus 2 squared equals r squared, which is just 20. The square root of 20 squared, the squared eliminates the square root, and we're just left with 20. Here's our standard form of the circle.